What's going on, guys? So today we're going to take a look at how to make a USB keyboard in Altium so I don't have to switch screens like this with OBS. So let's get started. So today we're going to be looking at the DigiSpark USB development board. It's an AT Tiny-based microcontroller development board, similar to the Arduino line, only cheaper, smaller, and less powerful. So what's nice about these boards is that they can be programmed in the Arduino IDE over USB due to a special bootloader that was written for the AT Tiny 85. If we go into the resources here, you can see there's a schematic available. So what we're going to do is have a look at this schematic, recreate all the components in Altium Designer except this giant 7805 that they're using for some reason. Yeah, I don't know why they're using such a big regulator on this board, so let's go ahead and fix that while we're at it. And we will take a look at this design in Altium. So let's go. All right, so I got Altium Designer open. Let's go ahead and create our new project. We're going to call this OBS keyboard, which I already have a folder created here. And let's go ahead and add a PCB. And we're also going to add a schematic. Give that a second to fire up here. All right, we'll add our schematic as well. And you'll see that Altium has just called these generic names, PCB1 and Sheet1. But if you hit Control S, you can actually save that as whatever you want. Let's call it OBS keyboard again for each of these. All right, so now we have our PCB document, which is going to be the actual circuit. So our traces will appear here. And our schematic is tied to this PCB document. What we're going to do now is take this AT Tiny and create a symbol. So for that, in Altium, we're going to create a new schematic library. That's going to be the symbol. So we're going to create the symbol. I'm going to edit this. And we'll call this AT Tiny 85. And what we're going to do is use U question mark. And this question mark will get filled in later. You'll see that. Not 65, 85. And let's put that as our comment as well. All right. So what we can do now is place a pin. You can hit P. That brings up this menu here. P is underlined here for pin, so we're going to do that. And we're just going to copy what we saw earlier. And this one is going to be PB0 Mossy. And it is designator 5, pin 5, basically, on the package. And we're going to do the exact same thing with all of these other ones. PB1, ISO master in, slave out. And that's not the designator, that's the name. And that is pin 6, and we'll continue on down the line, and once I get all these done, I'll continue on with the next bit. All right, so we have all of the pins named, and they match our diagram here. So what we're going to go ahead and do is you can place a rectangle, P rectangle, and encapsulate all of this. We can send it to the back. Move to back. Send to back. There we go. We got our nice little symbol now. You might be wondering how I got this line over top of this PB5. Well, in the schematic, it says NRES. I don't like to do that. That just means negated reset or negative reset, active low. So what I'm going to do instead is place a bar over top of this, which means the same thing basically. And to do that, all you do are these backslashes after every single thing here. So I can show you what that does. All right, so now that we have our symbol done, what we're going to want to do is tie this to a footprint. So down here is our footprint area. So before we go ahead and do that, let's just save this, and we can call it the exact same thing, OBS keyboard. And that's going to save as a schematic lib. So now our thing is saved here again. And so now that we have our symbol made up here, what we're going to need to do next down here is add a footprint. So what I've done is brought up the ATtiny 85 that we're going to be using, and also the data sheet. And in the data sheet, you'll see the drawing for this part. As you can see here, 0.208 inch package, which is a 208 mil package. So that's what we're going to be looking for in our leaded PCB, lib here. So what I've gone ahead and done is inserted SOIC 8 in here with our wildcards here. And I can see that here is a package here, WinBond SOIC 8 208 mil wide. So this package will work correctly. So what I'm going to do is go back to my schematic library here, my symbol library, and add that package. Make sure that it's the right ones that are showing up here. And 208 mil wide package, perfect. And we're also going to want to make sure, we're not done there. We want to make sure that this actually is the correct dimensions. So what we're going to do is go to our leaded library here. You can hit Control M. That brings up this cursor. And what we're going to do is we're going to verify the dimensions as in the sheet. So we can see pin to pin here is 8.8 millimeters. So if we go back to our page here, we can see E is our pin to pin outside edges. And that is going to be anywhere between 7.7 and 8.26. So our other one here, our package, our footprint, shows 8.8 millimeters, which means that our 7.7 should fit. Let's just double check our inside measurements here. 5.4, yeah. So our minimum was 7.7 on the data sheet, and this is anywhere between 8.8 millimeters and 5.4 millimeters, so our pins will match. We also know from the data sheet that our small e here is our pin to pin, our pitch, our pin pitch. So that's 1.27 millimeters, units of measure, millimeters. So we're going to go back to our footprint, Control M, and you can see how it snaps into the middle. And just double check, yes, 1.27. You can also check these overlays. I know that this is pretty much going to work out. So 5.2 on our data sheet. Let's read it real quick. D 5.13. So yes, our footprint is going to match what we've done with our symbol, and we can go ahead and save this now. So now that we've done that, we're back in our schematic document now. We can press P on the keyboard, and that brings up our place menu. And what we're going to place is a part. So PP. We're gonna PP on this document. And what we're going to do is we're going to go to our OBS keyboard, select the part that we made, and there we go. We have added our ATtiny85 to the document. And as I mentioned before, this question mark, we're going to what's called annotate the document, and this will change to a number. But we're not going to do that quite yet. We are just going to look at our schematic and see what's next. So we're back to our schematic document here. We've got one part done. We have the ATtiny85 is complete. And we're going to create this USB part. Something that they don't have here because of the USB bootloader is a in-circuit serial programmer, which is what's usually, which is the usual way of programming the ATtiny85. So we can go to images on Google and search up in-circuit serial programmer pinout for AVR. This is a Atmel AVR, well, microchip now. And what we can see here is a pinout for the in-circuit serial programmer. And this is a common pinout for all boards. You'll see this even on the Arduino Uno. The Mega has this. All of the AVR architecture microcontrollers are going to have this pinout. All right, so we're back in our schematic document here, and what we're going to want to do is also create the symbol and the footprint for the in-circuit serial programmer. So what I've done is I've created a common library that I use for most of my projects. Well, I'm starting to do that anyways. And what I'm going to do is I'm going to add it to this common library. So let's go ahead and make a new symbol. We'll just add a new component, and we'll call this in-circuit serial programmer header. And like before, we're going to create the same kind of symbol. Oh, and to rotate, you just hit space on the keyboard. And our rectangle of doom, we'll add that in there as well and send that to the back if we can. Sometimes it's better to do that in advance. And this is going to be MISO, and our designator is 1, 2, 3, 4, 5, and 6. Okay, let's spread these out a little bit. All right, so 2 is ECC, 3 is S clock, Mossy, 5 is reset, and ground. I'm just going to call this reset RST. There we go. So let's move this into position. Try to make your symbols in the center of this origin here, just to make things easier. So now what we're going to want to do is we've created this symbol, but so now we need to go back to our projects, into our PCB lib, for our common library, and we're going to create the ICSP. Sometimes I get that mixed up. ICSP header. We'll call it the same thing, and this is a 2.54 millimeter header. 3x2 header. And it's important that some header footprints will have a different way that they count the pins. Some of them will count 1, 2, 3 down the left vertical side, and then count up like a pin package. Or some of these will do the alternating pin pattern. So make sure that you're keeping an eye out for that. So what I'm going to do is add the header PCB lib and schematic lib into my project here. And let's go to the PCB lib. Let's go to the PCB library for headers. And let's look for a 2x3. And there isn't a 2x3, but you can see there's a 2x5. So what we can go ahead and do is just copy these pads. And when you hit Control-C, it's going to say, where do you want your reference point to be? So let's just go on number 1 there. And we're going to go back to our common PCB library. Let's not do that. Let's just paste right into here. And now we have some nice pads that have already been laid out for us. Let's just double check the dimensions. 2.54, 2.54. We can click on a pad, make sure our hole size is 1 millimeter. It is a multi-layer, which means it's a hole. It's going to go through the board. It's going to be drilled through. And the pads are 2 millimeter by 2 millimeter. Now I like to leave my pad 1 as a rectangle, and I'm going to select all of these other pads here, and I am going to make those ones round. So now I know what pin 1 is without doing any silkscreen or anything like that. You could also create these pads yourself, but that was a quick way of doing it. So let's just do that. Oh, and another thing is our ICSP header went from 1, 2, 3, 4, 5, 6 like this, not 1, 2, 3 down the side here. So double check that yours matches what you have in your new PCB library, or you're going to have a bad time. You don't want to have a bad time, so don't do that. So now we are in our symbol here. And what we're going to do is add a footprint, and we're going to create the one. Now, I saved this before I went into here, so it's a good idea to save it before you do that. And now we have our ICSP header, and now we can use this in all of our projects. But we don't want a designator like this. Let's call this ICSP, so we're not calling it like a port or anything like that. Just to differentiate them from all the other different headers that might be on the board later on. So we have this created. What we're going to do is check our pins, make sure they match. Go back to our let's go back to our pinout here. MISO is 1, VCC is 2. Yep, everything looks like it matches. So we are done with this. Now what we can do is go back to our schematic document. We're going to go PP all over this document again. ICSP header, let's do that. Oh, sorry, PCB lib. We want schematic lib. There we go. There we go. So now what we can do is start to connect these up. So you can hit P on the keyboard, and what we're going to do is place a wire, which is W. So W. And let's just create a few little leads here. I'm hitting escape after each one, or else I would connect the pins together, which I don't want to do that. And it's good to get used to the keyboard shortcuts so you can become faster. Place N for net label. And let's just go ahead and label all these really quick. I like to put them in a little bit so the right-hand side of the label is kind of flush with the end of the wire there. Net label 1. This is MISO, so we want it to be connected to PB MISO. So we're going to PB1 MISO. We're going to add our wires on to this ATtiny as well. Actually, I'm not going to add these yet because you're going to see why. If we start labeling these what we want them, I'm going to call this MISO. I'm going to call this, actually, I'm not going to put labels on those guys quite yet. Come back here, SCK, reset, Mossy. What I'm going to do for these VCC and ground is PO for power port. And you can see the different types of power port there. So we just stick that in there. We can change the type of power port it is. I like the arrow. And hit space while we're moving this. And we're going to add a wire to that. And we're going to PO again. And we're going to call this ground. And we're going to make this a power ground. Yeah, power. And we're going to move this into position. PW. Our wire is set up now. So now we have our full ICSP header here, and we're just going to go ahead and start naming these nets or connecting these nets up to our original here. And while we're at it, let's sync this ground and VCC and put them up here as well. And PW, there we go, PN, and we're going to call this Mossy. Oops. Mossy. Place and I'm gonna call this MISO and see how it auto completes for you there. And let's just go ahead. Oops. Let's just go ahead and fill all of these in while we're at it. Okay. So. We also want reset here. Now I'm going to change the name of this. Actually, reset is low. So let's give it a bar. There we go. So we don't get confused later on. Now these two pins here are whatever the hell we want them to be. So let's call them PB3. And we'll call this one PB4. There we go. So now we have everything. Now it's good to mention this ATtiny 85 has an oscillator built into it. So we don't need to worry about an oscillator, an external oscillator. Otherwise, you would be connecting that up as well. Let's move these away from each other. Okay, so now let's go back to our DigiSpark and check out what we have in the schematic. So we've added an in-circuit serial programmer. What that's going to allow us to do is program the ATtiny 85 for the first time, because these boards have them pre-programmed for the USB bootloader. But when we buy them off DigiKey, they will not have that USB bootloader on them, or on it. So what we're going to want to do next is probably add these decoupling capacitors, and yeah, let's go ahead and do that first. So we're back in our document here. We're going to add an existing to project, and we're going to go back into our master library, I think. No, we don't want to do that. Let's go back to our Altium library. Symbols, passives. We're going to add passive symbol library and the footprint as well for passives. And now we can add our decoupling capacitors. So let's go ahead and do that. Passive schematic lib. And we're going to add a capacitor. And we're going to rotate it. And let's add our two capacitors here. This is a 4.7 microfarad. And this is a 0.1 microfarad, which it already was. You can also see the parameters here. It was set to equal value for this one. That's why it was already like that. But we can see that our value is not correct here. I don't really like these. Let's get rid of them. Yes. Yes. Because our comment is what I'm going to go by. And since we already have VCC and ground right here, I'll just connect them like this. That's actually, I don't really like doing that. Let's do it the way it should be laid out on the board. VCC and ground should kind of be on this 4.7 microfarad first, then the 0.1 microfarad. And then from here, this capacitor should be coupled to VCC and ground as close as possible. And it should go in that decreased order for capacitors, usually the largest value on the outside and then the lowest value closest to the power pins that you want to power. So it's a good way of laying out your schematic like it's going to be on the PCB is kind of the best way to go, I think. It makes it less confusing later on. So we've created these two parts. What we're going to do next is try and create the USB part. So we know our USB is going to provide 5 volts. And all right, so we've got this done. Let's go ahead and save this. You can see that these have a squiggly line here because there is no number for this capacitor yet. So let's go ahead and annotate. Under Tools, Annotation, Annotate Schematics. What that is going to do is put numbers in place of these question marks. So if we update the changes list, 4 changes were made, you can see now that the designator is going to change and they're going to get a number. And we'll accept these. Engineering change order, or ECO, accept changes, create ECO. So as the engineer, we're going to have to confirm and validate these changes and execute, or you just execute. Done. Close. So now when we've closed, all of our designators have changed, and now we don't have a squiggly line there anymore. Perfect. Let's save this. All right, so I hope you enjoyed that little rundown of how to use Altium Designer. That's kind of like a beginner's guide to using it and using different parts like an AT Tiny 85 in your projects rather than just using an Arduino. In part two, I think we're going to go a bit quicker. That was quite a long video, and we'll do the rest of the DigiSpark, and I'll just quickly slap it together and maybe go through some of the harder points and stuff that people might get stuck on. So, all right, join us next time. See ya.